Obviously, anybody that's involved in the making of the infrastructure or the application that produces those results. So if it's, I'm responsible for that web app and that has an issue or has a configuration issue you found, they need to see it. Some organizations I've worked with are, every engineer could see that. They could see any metric on anything. They believe heavily in situational awareness. If a change is made over here in this microservice that consumes 1,000 VMs in 5 minutes, and all of a sudden they're hitting all the APIs, and all of a sudden you're over here like trying to hit that API, and you're like, I'm getting rate limited. That's weird. I can't make it. You need to see that somebody else is also using some of that capacity. Other organizations, maybe federal specific, might say this is a need-to-know basis. This is extremely tight set of folks that need to see this. It's the best and first is who's responsible or owns the ability to fix the change or fix the configuration or the issue, at least. Bubble up what you can in a nice dashboard. I hate saying those words, but there are ways of visualizing these as time series metrics, and you could show them on a trend line. Like, here's our compliance, here are specific items. We use Prometheus and Grafana heavily for that. So you take some JSON out of the run of the output and go, here's some metrics, track these. Every time I run a change, you'll get a data point on the graph, and you can see, is it valid or not valid? I'm not picking Chef Inspec because I'm repping Chef or anything like that. It's one of the tools that I found that covers the most ground and is easily grokked, personally. I do write a little bit of Ruby, but not much, so you don't need to be that Ruby experienced to use it. But Chef Inspec hit home when we were using ServerSpec, which is just a way to SSH into a system and say, is this file correct? Is this directory here? Is this process running? Chef took that and ran with it a little bit. Use that same paradigm. You can test almost anything that has an API or a way to execute commands. And so I like to use Chef Inspec as an example of something that can test very low level or very high level. And it's the same policy language and the same reporting mechanism. So I do have a demo environment. And I'm going to run through it. It's a video, so I can run through it a little bit quicker. But this is what I've built with Terraform. How many people have used Terraform before? Okay, a couple. Declarative infrastructure as code. I would like a VM in this subnet. Those are two things you specify and link them together. But fundamentally, it's code that says, go make this infrastructure. So I can have, I don't know, 300-400 lines of Terraform, which is basically really readable JSON, kind of, and say, go make this entire picture you see right here in probably 9 minutes runtime, wall clock time. Nothing fancy about that, but just understand that I can build and destroy this demo and then test and destroy this demo very quickly. So take that and extrapolate that to your larger sizes. Things that you might want to look at, and I think the lines are sort of visible here. These green lines are from the perspective of the auditor, the security person, the blue team, somebody that wants to check their own infrastructure. You're not going to too many different places, and you can ask a lot of questions about a lot of things. Is the project set up? And that's GCP terms, it's like an AWS account, but a little bit smaller, but think of it as that. Is the VPC, the network, generally set up the way that I said? Is it still configured that way? Is that subnet that I created still those CIDR blocks? Did somebody change it? Did they add a route? All those questions you can ask there. And then because I run a lot of Kubernetes, it's really easy. I have quick code to show this, trying to show the higher level items. I can create a GKE cluster, validate all the settings of the cluster that you possibly can give it, and then create a workload inside that Kubernetes cluster and validate that is configured correctly. I don't have things yet for inside the container, but inside the container, in theory, could be shifted way left when you're building the container if you want to go to that level. So you can cover everything that we built all the way up to the very tippy top with Inspec in this case. So I have a demo here, and that is, apologies for it being a little small, but you have the benefit of something to your right there. So, move this out of the way. What I want to show is the Terraform code that I'm using to build this entire picture that I showed you. And I can't type in front of folks, so I apologize for the video part, but you would just see me destroying my keyboard. So At the top, I'll break it down a little bit. So you see the resource, that's an individual item, that's an individual API call to go make something, right? So create a service account. Add the service account to that project, add roles to it, add the services that that project is allowed to enable, add a public IP address, create a network, and I called it GKE sec-network. Create a subnetwork, GKE sec subnetwork, that's at the very bottom. All of this stuff you can copy paste, like you don't have to write this from scratch, you can pick and choose, there's a whole library of these that you can pull from. But fundamentally, I'm just taking Lego blocks, right, and putting some variables in there and making infrastructure with Legos, right, in a declarative way. So we'll look at the GKE cluster. Okay, I'm saying what project is it in? You can see my mouse, correct? Yeah, it shows my mouse. What region it's in, the network name that we linked by name, the subnet, the version, should logging be enabled, should monitoring be enabled, types of authentication and authorization. These are all settings that you're sending to the API, say, go build this cluster, here's how, right? Those are all the same things that you can then ask, how was it built? All of it comes right back almost the exact same way, same format. And I'm just showing all the security settings that go into a GKE cluster. I was trying to do a whole bunch of them to show that this is a complex example of an API that you can hit and ask questions of. So you can see it's a couple hundred lines of code, but if I ever want to build this again, I literally just copy the repo, change a couple things, and I get a different output. But fundamentally, I didn't have to rebuild all that from memory and custom bespoke code. And I want to go into, these are the systems that are part of the cluster that actually run the workloads. So it's on a 100 gig disk, it's running container optimized OS, it's running a standard SSD drive, those kinds of things. I call attention to these items because these are the things that we might be showing when we test. Okay? Let's see if I can. So I ran a little bit ahead, there we go. If you run Terraform plan, I'm just like showing my arms. I don't have any cards up my sleeve. This is real infrastructure. It validated that it created the way that it did and nothing had changed.
This is running on GCP or on AWS?
GCP. All the same things, very good point. All the things I'm talking about apply to AWS, just point at the different APIs for the different resources. I get credits on this platform. Sorry?
Is there a middle layer? Because it's actually hard to transition from the three various cloud platforms.
Terraform is one of the better ways to do it. Troposphere, there's some others that, but there's so, like leaky abstractions are really a problem, and naming things and interdependent, it's really hard to tease that out and be very, very general, yet still get that specific feature bubbled up. So it's hard to say, I can write my cloud and point it at any cloud code and say, make that, and it comes out the same way. It's not going to be there.
Okay.
So a Terraform plan. All right, all that infrastructure was made correctly. No, there was no changes to make here, right? And I wanted to show in the UI, because some people visually don't see in the CLI. I see both, but that's the network I created, that's the subnet I created, that's the project I created it in. Here are the subnets I said I wanted that to be made with. There's the gateway. Here's that GKE sec cluster that I made. It's in that region, has that many nodes. It's that version, has, those are the zones that it's running in. Those are the same networks, again, bubbling up. The pod ranges, the service ranges, those very basic authentication settings I put in there, all those are the same that I showed, right? So we want to make sure that this doesn't change. Somebody doesn't come in the UI and click this and change it without you really knowing every time, right? So this is grunt work. You wouldn't want to assign a human to this. You want them to be running a testing suite or something automated running this testing suite, validating that this is the same and has not drifted without you knowing. So I'm just showing the gcloud command. So this is just list me a cluster. This is an API call. And there's actually more data behind this if I were to expand it, but I'm not trying to go into that. Here are the 3 nodes that are in that cluster that I mentioned. And there are there's no applications running in this cluster that are user facing, right? We're showing an empty world, an empty infrastructure ready to do things. So I'm going to run some Nginx. That's always the hello world of Kubernetes, right? Show that you can run a web server. And there it is. I just started a web server. That's what Kubernetes can offer you. Everybody give a round of applause for Kubernetes. No, kidding. So I have basically the most simple example possible of everything from the bottom to the top that I could fit in a talk. It's running. I paused in my recording so that I could talk a little bit about it, but sometimes the pauses don't line up. I just hit the API of the API server, the cluster, and I said, tell me everything about that pod I just created, that Nginx. There's a ton in here. Wait, I didn't specify all that when I made my Nginx. I said one line, it was like, please run Nginx. And it went and did all this stuff, created that app, has all this metadata, all this stuff is automatically added. But Brad, you said everything that you put in is what you get back out. Not so much. Sometimes you say, please make this one thing, and the cloud provider or the API will go, oh, and you also get all these other 50 settings by default. So you can't just check your code as you're generating, right? As you're trying to create the deployment, you can't check there and go, I know exactly what's going to come out the other end. You still have to validate what came back to you. So that's why testing. Yes?
Just before you comment, don't all audits need a baseline? I mean, so you're talking about this extra information, but isn't that no different from any other audit that needs a baseline?
Is the...
So, like, the extra information are defaults, right?
Yep.
Which
may or may not be default,
Routers.
depending on other configurations that generate them.
Yeah, so what I'm asking is, in any other audit that's not using Kubernetes, aren't you expecting a baseline? Don't you have a baseline to work off of?
Maybe.
Okay.
You might have a baseline. You might not. I've seen it more often. I'd say it's 50-50. This is swagging, but like what you're sending in, you often get back more than what you submitted, even though it might be a default. The cloud provider might change that default. The company I work with often changes the defaults on you.
But when you configure a router, right, like you're still working with a baseline, like iOS comes with certain defaults.
Depends on the version, depends on the firmware, depends on the feature set, depends on the license, depends on
It still
anything.
comes with
Right?
defaults, yeah. What
Right.
defaults are depends on all those things.
Sure. Test that first and then test the deviation if you like.
Right, but what I'm saying is, isn't the Kubernetes test the same thing? Isn't the cloud provider Kubernetes test the same thing as testing your router? It's a default, and then you're adding stuff on top
There's
of it.
so much, there's such a variability matrix. It'd be darn near impossible to say that that's, I know of things that have changed under the hood on a customer, day one to day two. Like, that didn't used to be there. Yeah, they rolled that feature out last night to all the regions. Okay, I got a new thing now that's part of my defaults. So like, that is actually an important thing to detect in terms of drift that you created, but drift that the API owner backend service created for you. Yes?
Well, to be fair, that doesn't happen in every cloud environment. Right, so if you're running in, say, AWS on EMR, they give you a version,
Mhm.
and they do not change the base. It just stays the way it is, and you need to rev to the next version of the EMR because they're aware of this, and they don't apply security updates to the operating system. If you want the security updates, you have to apply them.
Sure.
So
So not every API is like that? and
not every API is like
changes
that, not every VM in GCP is like that. There's a lot of variability.
Mhm.
And the containers are supposed to limit the variability, but they don't.
Yes and no, mostly to the no, and like 60-40 no. They consistently make certain things very well. The environments that they run in have high entropy.
So, what experience have you had hatching containers for which you can't rebuild them? There's lots of consulting firms out there that are delivering containers to the government as their deliverable. And their government customers don't remember that they need to be able to build the container after the consultants leave.
Yeah, so take that as an action item to your statement of work deliverables. The ability, like, you could do it like, you know, the removing the yellow M&Ms from the rider.
Yeah.
Right?
We know the
Show
right thing to
me,
do.
show me,
Right.
like, I deleted this developer's laptop. Like, here's a fresh laptop, right? It's probably easier to say. Here's one of our government laptops or Fed contractor laptops. Take your code, put it on here, and deploy everything. That's the litmus test, right?
Right. So in other words, your experience is you can't patch these containers.
No, what I'm saying is if you don't have the source, you don't have the ability to regenerate it the exact same way. That's a different problem. But I'm saying like the environments that you hit, you say create me a default cluster or create me a default VM. You hit it one day, you hit it the next. There's a chance the settings that came back where things are different. If you hit it in different regions, as providers are rolling out different versions in different regions, you'll get different answers depending. So I'm just saying is, here's a way to know if either you did something that made a change or they did something that made a change, if and when it happens. You want to know that. Be like, wait, we didn't make that change, provider did. Good. Incident resolved, we know why.
Okay.
So I'm just showing you I did a bad thing on purpose using Nginx latest. You never want to use latest as an image tag. You want to use at best as a SHA hash to know exactly that that's the container. You can validate all the layers, etc. But at least a version tag is better. So I'm purposely showing you that because we'll test for that. Okay, so we have our workloads. Now I want to show you the test code, the inspect profiles. So we have 4 sets of files here. It doesn't have to be separate, but I named them this way. We have a project. So what's the foundation look like? What's the network? So that's maybe the walls. The cluster is the kitchen, and the node pool is the food in the pantry, we'll say. That's a bad analogy, I just made it up. But with, I don't know, what is it, 20 lines, 20L, 20 lines of code, not even that much of it is code. All of this is like sending in variables and making a control structure. But this is, hey, get me the project. I can't highlight a video. Why am I doing this? Sorry. Google project right here. Get me that object. So you're saying, hit the API, describe project. You get back this bundle of JSON under the hood, right? You can say, well, it should be present. That's kind of an obvious one you think, but guess what? Sometimes that actually fails. The project number should be this. Sometimes the project numbers and names don't line up because it was deleted when we created. Is it active? Is it not in deleting state? And is it part of the correct organization? That's another one, right? These are canaries. Really simple, quick checks. Is the state of the foundation, correct? And honestly, this runs in like half a second, to a second. So you're not even spending a lot of extra time in the time of test to validate these things. So the next thing I'm saying is the network that I'm creating correct? Does it have a very specific security setting called auto create subnet? False. And then the subnet below, again, detecting configuration drift. I've seen folks that modify the CIDRs in the UI and it breaks something and they have no idea why. The next time they run their automated code to say create the infrastructure, it deletes and recreates the object. Meaning it deletes the subnet and recreates it. You can imagine that's not a good day, right? So you want to make sure that these things have not changed. This is, again, the walls of the house. There's a little bit of a delay because I was going to talk a lot more about that. I should let it run, honestly. So here's my GKE cluster. What region it's in, the status, is it private, is maintenance window set at a specific time, are all these security settings set or not? Is the CIDR ranges that it's using correct or not? Let's look at the node pool. Same thing, is it running ContainerOS? Is it this version? Is it the disk 100 gigs? Is it SSD, not a standard spinning disk? You don't want to have a performance issue without really knowing, right? And then let's check the workload. Some fake things checking about the namespace, etc. But fundamentally, this is the line at the very bottom, like making sure that images don't have the tag latest. That's a one line of code to say, look at the entire cluster and say, are any of them latest? And, okay, it's running. Just like 2 seconds, here we go. So I want to run the test. I encapsulate everything in Docker containers because there's a lot of dependencies in Inspec and custom things I threw in here, but basically it's 2 tests. Test all the GCP stuff, and then that one says test all the Kubernetes stuff. Okay, I hit test, and this is going to play in real time. I think it's like 15 seconds maybe. But I show the progress output, so every one of those green dots is an individual check of some spec on one of those components or resources. As you can see, we had 5 total controls, but there were checks inside of there that count. So there's 47 total that were successful. Oh, we had 2 failures on our workload test. That's crazy. What? What did we do? Okay. So I wanted to show that all these are correct. I'm going to fast forward this. That's sort of where I want to get to is we validated all those settings that I had shown before. Now the astute readers might say, well, why don't you take the variables from your Terraform and use them as a part of your test? Well, guess what? If you make the incorrect change in your code to make the infrastructure, your test will go, yep, that's correct. So it's purposely separate. It's purposely 2 different personas. Imagine this team is creating the infrastructure over here, and another team is making the test harness or is working closely to make the test harness that validates what they did conforms to the baseline. If you share the data used to create the infrastructure with the data that's used to generate and run the tests, you're always going to be right. That's weird. You're never going to notice the difference. So I noticed that this test, there's 2 failures. I didn't want any pods in the default namespace. That's a smell. You want them in dedicated namespaces, etc. And then there's my container that has Nginx latest in its tag. All the rest of the containers do not have that. So you can pick out that that's the one that's the offending one, Your Honor. Let's get rid of them. So I can skip this. I was going to delete it and then show you the test pass. But let's swipe over this way. That was going to be the end of my talk, and I honestly went longer than I expected. But I saw a talk in B-Side San Francisco from the Lyft team, the security team at Lyft, who did a cartography project and a talk at B-Sides. And I was just like, that just reframes the problem so much better in ways that are different, right? So I'm not saying what I just all went through was bad. Don't get me wrong. There's another level to this. So cloud inventory and graph databases. I'm not going to go into too much detail about the theory and all that behind it, but basically, it's an efficient way to store relationships between objects. If everything you have is a JSON API, you can grab all the things. And if you know that a project is inside of an account, then you can make a link. And then you can ask really good questions. You say, show me all my AWS accounts. Once you get past 5, it gets really annoying to do this. Show me all the RDS instances inside each of those accounts. The thing is like, yeah, that's a simple relationship that doesn't really tell you anything. But every single one of those little red circles that represents a new database has a version, has when it was created, has security settings. You can now filter when you ask that question. Show me all the accounts, show me all the RDS databases, show all the ones that are publicly exposed, and are this version, because guess what? That CVE specifically is targeting that, okay? So historically it's called a change management database. When have they ever been perfect? And that's why I put the quotes around it. But I was like, immediately I realized what we're searching for to reduce toil in cloud security environments is ultimately searching for the perfect inventory. Because the first thing that you do in any of those tests is state the thing or find the thing or discover the thing to test. What if you always knew that correctly and you knew every attribute about that thing you could possibly know about it ahead of time? You can ask really good questions. You can map the relationships and you can query that. So the questions you might ask, I already alluded to the one, but like, show me all the publicly exposed Windows instances with RDP. Show me all the public cloud storage buckets. Show me all the users that have admin role to this API. It should only be these 4. If there's ever a 5th, let me know. I'll know when that test fails. Run that every 20 minutes. I don't know, whatever frequency. 1 second. Show me all the containers in my Kubernetes cluster that do not have a patch for this CVE. We're talking about the patching thing, that's why I want to get to that. You can hit your Docker registry and ask for the vulnerabilities of that, and then understand which SHA hashes or which tags are hit, and then you can go ask the cluster, are you running any of those images? You can put 2 and 2 together and know your exposure. What's really interesting is when you get to attack path mapping, automated compliance reporting. This is where I'm at. This is part of the journey where it's like which way to go, which is the best. Haven't been there in terms of maturity with the clients I've been at. We're up to this point, kind of. What can you do next? If you know everything about everything, you can automate a lot of things about the state of configuration about those assets. If you get that inventory every 2 minutes, or as every single change is made, your cloud provider provides that to you, AWS Advanced Config, Google Cloud Asset Inventory, you can ask, what's the state of my infrastructure? What's the state? Literally get a timeline of all the changes every 5 minutes, as often as you need to, and you know up to that minute everything about your environment. If you feed that into that graph database, you can ask those questions every 5 minutes. And you would know immediately very complex things that changed. Generating threat models, a lot of the infrastructure I see is cookie cutter. You know, like I have this one cluster, I make it with Terraform. It's very repeatable. I need 1,000 of them. Okay, 1,000 of them. You don't need to rewrite or change threat models for some of those basic components. You can write it once and apply it to all those things. Wouldn't it be nice if that was sort of part of the code or part of how you generated those threat model matrices? That'd be great. You can apply risk scoring. If you were to do, like say, let's take an example of a pod that's compromised in a cluster, right? Think of it like a VM in vSphere getting compromised. Sit on it, think of it as you're sitting on a shell. What can I see? Okay, I can see that, I can see that, I can see that. Okay? Assess the risk of those items. Say, okay, assume I get to that next point on that next system. What do I see? What if that's a really easy path? What if it's like no authentication and it's just really easy, it's in the config file, you know exactly where to go? That's a high-risk attack path. You could, in theory, run those over and over and over, iterate across all your assets, and know really soon after it was deployed, and as you mature before you deploy, what changed in your environment and what impact that was. So what I'd like to get to at some point is that bottom bullet point. It doesn't exist as far as I'm aware. Everybody says that there's marketing material to get there, but simulating changes and measuring risk score changes ahead of time. If I have a graph database, clone or copy or do whatever with the transaction, add the thing I'm going to add, right? Test if there was a difference in the score. If the score went down, then, or up if it's bad, then whoa, stop and halt the change, let's look at this. You know, you went from a 10 to 100 here, that's a severe critical, we don't allow that to happen. The point of it is by automating these tests, you're codifying your policy in a central way that everybody can interact with equally. So if you say, this is my capital C compliance or lower C compliance, here's all the things I test, you can be very efficient in expressing that to all your teams that operate under those structures, right? So anytime they add a new application, all right, run the test harness against it. What does it see? There's 5 deficiencies. Okay, well that is something you know of ahead of time. Once it passes those, it's allowed to go into the next stage or whatever your process is for certification and accreditation of the last bits that it doesn't cover. So you're just eliminating toil and automating a lot of that out of your life. And with that, thank you very much.
How do we get the slides? How do we get the slides?
I will share through the ISSA group.
Post it on the site.
Yeah, that'd be great.
Great.
There may be a lag because we have to photocopy them.
Yeah.
We don't have an API for that yet.
Again, thank you so much for both of our speakers tonight. Thank you for coming out. Again, I always thank our host, Alex Pryor, who's back there. Without him, this doesn't work. So he's the one who hosts us at this great location every month. So again, a big shout out to him. Brad and Kelly, thank you again. Will you guys be around to answer any more questions? Okay, so let's stick around if you have any additional questions. Again, the only thing we ask is that you take care of your trash. And again, thank you for coming out. Cool.